I'm learning in this process that silica gives strength to the stems of plants.
Yeah, just the same as it does to our bones.
Yeah, right.
Okay,
It's very
and-
structural.
Yeah, and the most structural part of all our body, which everything hangs off, is our hips. And if you,
Yes, I know.
Yeah.
No,
and
but-
if you got hip problems, you've got silicon problems.
Indeed.
Yeah.
I hear silica and silicon used interchangeably. Does it actually matter?
Yeah, well, I do it as well. I mean, if you want to break it down, I've said before, there's 125 different forms of silicon or silica.
Right. So
Okay.
of course we use it interchangeably.
Interchangeably, because there's so much. And there's just understanding the different aspects of it and what it does. Is it an electromotive force, or is it a plant available food, or what is it structural? Like it has many aspects. I mean, up until probably 20 years ago, they didn't regard silicon as a necessary plant, one of the 15 essential plant elements. And I'm going, and then they changed their mind.
Because they saw what plants are like without it.
Well, yeah, well, they don't grow. So especially tall grasses don't grow without it.
True. What role did marine clay and its fine particles play?
Well, that's what I just said before about it was the electrical side of it. And you've got to see how fine this stuff is. I mean, when you get it in your hands and you rub it, it disappears.
Wow.
It like there's
Into you?
Well, part of me, but it's so fine.
Yeah.
And there's a word for it called cryptocrystalline, which is nearly in the atomic state. So what you're looking at,
Wow.
even though that's clay and it's packed like this, and you break it open and you put a bit of moisture on it, spin on it, and you rub it, it's just gone. Where'd that go?
Wow.
And the surface area said from that size, 1 square inch is equivalent to 7 square miles of surface area.
What?
So this is how effective an electrical producer is if it's spread over a large area.
Wow.
So that's why we don't have to use a lot of what we call probiters, the electrical side of it, because it's so efficient at converting a UV part of the sunlight into electrical activity.
That's just incredible. What discoveries did you make during the 12 months of mixing trials and soil experiments?
How to grow tomatoes out of the greenhouse and coming down and we had all sorts of funny things. Like one of them, we actually created a cyanobacteria explosion inside the greenhouse, and we had this foam go right across the floor of the greenhouse. I'm sort of going, what the bloody hell?
Cyanobacteria foam.
Yeah, it was exploded everywhere.
What colour is it?
Oh, it was a pinky colour. It was just like being in the ocean. It was wacko. I've never been able to do it again.
Yeah, I wonder what your exact circumstances were.
Totally. But, like there was parts there that it just exploded. Other parts were not so good. Okay. And different parts of the farm we put it on, and all sorts of things were just, I'd go and stand, half a mile away and look at these plots on the hill.
Yeah.
And some of them would just stand out and go, zoom over there, go and have another look, because you got a different colour view, and we noticed different variances. And basically, after a while, we just like, well, that one there and that one there, they work. Let's go to it.
Yeah. Well, speaking of which, can you talk to the importance of establishing a baseline?
Oh, God, yeah. This part of agricultural or supposed scientific trials, if you don't actually start a trial with a baseline of actually knowing what your mineral status is, what your limiting factors are, you're not doing a trial at all.
No, you're just sort of hitting and hoping, right?
Absolutely. I mean, I knew all the numbers.
You're sort of back in the moron mode, putting more on.
Oh, it's stupid shit. They're like, we're going to do a trial on phosphate. And go, okay, so how many soil types have you done it on? Oh, we just done it on this one. And on this one, we got a 20% increase in production. Oh, yeah. So what about the volcanic soil down the road? Oh, we didn't do one there. And so, well, what were the base saturations and the mineralogy of the soil to start with? Oh, we didn't check that before we started. Well, what's the Olsen P? Oh, we know what that is. That's 30.
Yeah.
And so all of a sudden the 20% increase came from supposedly the superphosphate or lifting the Olsen P. Was it to do with the calcium or the sulfur? Was there other minerals in the soil that had anything to do with that?
Lime?
Totally. Was there enough calcium in the soil? Was it all these things? And this is the part where Albrecht, when he saw something grow really well, he worked it backwards.
Okay.
So he'd see, this plant grows excessively well right here. And then they'd go and test it and go, okay, so now we understand what the factors are, why it goes really well here. Because over there it didn't, and I have the test here and I can see the calcium was 20% less and it wouldn't grow. And I mean, he was prolific, and his students must have been unbelievably active because they were doing all these trial plots. They were putting extra lime on. They'd have 10 samples from the same soil to start with, and then start adding different products to different trials to see the effect on trying to bring the soil back up to an optimum level. That's science. It's like, this is what we've got now is just mumbo jumbo.